Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on October 22nd, 2025, about 3 days ago. This paper shows that Muon and SOAP beat AdamW for training diffusion models on dynamical systems, delivering 18% lower final loss. The paper is titled Optimization Benchmark for Diffusion Models on Dynamical Systems. And as we'll see later, the implications for model training are quite significant. Beyond the headline, the study benchmarks several modern optimizers on a U-Net diffusion model, probes learning rate schedules, highlights a persistent gap between AdamW and SGD, and reports mixed outcomes for schedule-free and prodigy. Alright, the intro highlighted an 18% gap favoring Muon and SOAP. Figure 1 compares optimizers head-to-head. The left panel plots final validation loss versus learning rate, which shows SOAP and Muon reaching their best near 1 times 10 to the minus 3 and sitting well below AdamW. The right panel tracks loss over epochs. SOAP descends fastest per step, and Muon stays close, while AdamW and schedule-free remain higher throughout the run. So, Figure 2 drills into whether extra training lets AdamW catch up. The left panel plots AdamW final validation loss across learning rates, with dashed baselines marking the best Muon and SOAP losses, and the AdamW curve stays above those lines. The right panel shows the best AdamW run extended from 1024 to 2048 epochs, which still does not reach the Muon or SOAP baseline. The takeaway is clear. Longer AdamW training does not close the roughly 18% gap. Well, the previous figure showed that extra training did not let AdamW catch up. Figure 4 compares learning rate schedules. Panel A plots validation loss versus peak rate and shows cosine and WSD achieving similar minima, with the best WSD rate about half of cosine, while square root underperforms. Panel B illustrates the schedule shapes, which clarifies why WSD is flat, then cools. Panel C reports comparable best loss curves, and Panel D shows gradient norms settling lower for cosine and square root, while square root tends to give steadier generative quality. So, Figure 4 contrasted schedule behavior and stability. Figure 5 shows a persistent gap between AdamW and SGD. The left panel plots final validation loss versus learning rate, and AdamW achieves a clear, lower minimum across the grid, while SGD stays higher even at its best rate. The right panel overlays training curves, where the best AdamW run descends quickly and stabilizes lower, whereas the 5 best SGD runs plateau higher and fluctuate more, which signals a real performance gap despite tuning. Okay, the previous figure highlighted a solid AdamW versus SGD gap. Table 1 summarizes the default training knobs for the benchmark. The left name column lists items like warm-up, learning rate schedule, gradient clipping, batch size, epochs, momentum, and AdamW betas. The middle default column sets 5 epochs of warm-up, linear decay scheduling, clipping at 1, batch size 32, and 1024 epochs. The right comment column clarifies scope, such as momentum applying to Muon and SGD, while the AdamW betas apply to AdamW, prodigy, schedule-free, and SOAP. Okay, Table 1 set the default training knobs. Figure 7 compares the best runs, with the left panel plotting training loss over epochs, and the right panel plotting validation loss versus wall clock time. SOAP traces the lowest curves, and Muon stays close, which indicates faster convergence, despite higher per step cost. AdamW remains noticeably higher, while schedule-free tracks AdamW early but drifts above it by the end. Alright, Figure 8 shifts from curves to visuals. The panels show vorticity snapshots for 2 generated trajectories, 5 frames each, using the best hyperparameters for each optimizer. Muon and SOAP produce sharper, more coherent swirls that persist across frames, which signals better denoising of the flow. AdamW looks slightly blurrier with muddier filaments, and Prodigy shows occasional artifacts and less coherent structures. The qualitative ranking matches the loss results reported above. Wrapping up, 2 takeaways stand out. Muon and SOAP consistently beat AdamW for diffusion training on fluid trajectories, dropping final loss by about 18%, and learning rate schedules shape generative quality so identical losses can hide real differences. The persistent AdamW versus SGD gap suggests deeper architectural causes. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.